In this video, we will discuss 3 properties of addition and 1 property of subtraction. And then at the end of the lesson, we will also discuss how to add numbers together. So beginning with the first property, we have the commutative property of addition. And this property says that the numbers in an addition problem can be rearranged without changing the answer. So for example, we have 5 plus 4. That is the same thing as 4 plus 5. All right, notice the order of the numbers that we are adding does not change the final answer. So that is your commutative property. And in math notation, we can replace the numbers 5 and 4 with the letters A and B, where A and B are just representing any number. All right, so here we see in math notation, A plus B equals B plus A. The order of the numbers are changing. And a way to remember this is the commutative property is we can look at the root word commute. So commutative, you see the word commute. So the word commute, spelled with a E at the end, the word commute means to travel or to move. So for example, your parents might commute to work, meaning they have to make a drive to get to work. All right, so commute has the idea of moving or traveling. So in this context, okay, what is moving or traveling would be the numbers. So if we move the numbers around, it does not change the final answer. Right here we see the 5 and the 4. We have 5 plus 4, but if we move the numbers around, so the 5 goes over here and the 4 goes in the front, notice the numbers are moving. So that is the idea of commute. So that would be your commutative property, is when you're moving the numbers around, and when you do that, it does not change the final answer. The next property is the associative property. So the associative property says that the grouping of the numbers in an addition problem can be rearranged. All right, so what this would look like is if we had 3 numbers added together. Let's say we had 3 plus 4 plus 5. Now the associative property says that it doesn't matter if we put parentheses around the 3 and the 4 and add these numbers first, or if we put the parentheses around the 4 and the 5 and add those numbers first. So if we try to add this, so on the left side here, 3 plus 4 in the parentheses, if we do that first, we get 7. So we have 7 plus 5, which equals 12. Notice on the right side of this equation, if we add the 4 and the 5 together first, what we have is 3 plus 9. And 3 plus 9 is still equal to 12. So we have verified that it does not matter how we group together the numbers in an addition problem. All right, we can group together the numbers in any particular order. So that is the associative property illustrated. And then in math notation, we can replace these numbers with the letters A, B, and C. So here in math notation, we see the parentheses around A plus B, and then the plus C on the outside. That's equal to A plus, and the parentheses over here around the B and the C. So that is in math notation how we write the associative property. Now a way to remember this property is in the word associative, we see the root word associate. All right, so the word associate, we can see in that word associative. Now the word associate in English has the idea of being in a group. So for example, like if you associate with a particular group of people, that means you're part of that group. You associate with them. So same idea here with numbers. If we associate numbers together, that means we put them in the same group. So the word associate has the idea of grouping. So if you see the grouping changing, and in this case the grouping is the parentheses, that's how we group together numbers. If the grouping is changing, or the parentheses, the numbers in the parentheses are changing, that would be your associative property. So we have the commutative property, we have the associative property. The third property for addition is your identity property. Now this property says that adding 0 does not change the original number. So for example, if we have 6 plus 0, adding 0 doesn't change the number, right? It's still going to be 6. Another example, if we had the number 100. Okay, if we add 0, we still have 100 as our answer. Adding 0 does not change the original number. We started with 100 over here. We're going to end with 100. All right, and then in math notation, we can replace the number 6 here and here with the letter A. All right, so we just keep this in general. A can be representing any number. All right, so here we have A plus 0 equals A. And that is the way we can express this property in math notation. Now, a way to remember this property is if we think of the word identity. Okay, if you are told that someone is changing their identity, okay, what that means is they're changing the way they look, right? So in this context here with math, all right, the identity property says that we're not changing the way the number looks. All right, we started with a number, so we started with, say, 100. Okay, that's your original look, or so to speak. Adding 0 doesn't change the way the number looks. It's still going to stay the same. So it does not change the identity or the value of the original number. All right, so that's the idea with the identity property. And then our fourth property is a property dealing with subtraction. And this one we can just state as the zero principle of subtraction. So it's kind of like the identity property, but instead of adding 0, we're going to subtract 0. So subtracting 0 also does not change the original number. So for example, if we had 8 minus 0, our answer is still going to be 8. It doesn't matter the size of the number. We can have 1,000 minus 0. That would still equal 1,000. It does not change the original value. So this is the zero principle of subtraction because we're dealing with zeros and subtracting. All right, so it's like the identity property, but instead of adding, we're subtracting 0. And again, in math notation, we can replace the number 8 with the letter A. So A can represent any number. So we have here A minus 0 equals A. So A can be 1, could be 2, could be -4, doesn't matter. Any number minus 0 will be the number you started with. So those are the four properties. We had commutative, associative, identity, and the zero principle of subtraction. So on the next slide here, we're going to get some practice with those four different properties. So you can get some practice with this. You're welcome to pause the video at any point to see if you know the answer, and then unpause when you want to check your work. So here are a couple examples. First one, we are given 8 plus something equals 8, and what we're trying to do here is we are filling in the blank and also naming the property. All right, so the blank would be 0 because 8 plus 0 equals 8. And this property is your identity property because your identity property says that adding 0 does not change the identity or value of the original number. Our second question, here we see 4 plus, and then parentheses around 5 plus 7. Over here we have a blank plus 5 in the parentheses, and then plus 7 on the outside. All right, so in the blank, notice the number that is missing on the right side is the number 4. Right? We need the number 4 to match up with what we have on the left side. And then notice what's changing in this equation. What's changing is the grouping. Right here, we have the 5 and the 7 grouped together. And then on the right side, we have the 4 and the 5 grouped together. So the grouping is what's changing, and that would be your associative property because we're changing the association or the grouping of the numbers. Third example, we have 6 plus 7 equals 7 plus something. So the number in the blank would be 6. All right, 6 plus 7 equals 7 plus 6. And what's changing in this problem is that the numbers are being moved. Right, we move the 6 and the 7 around to get 7 and 6. So the moving would be your commutative property, because remember the word commute means to travel or to move. Next example, we have 7 minus 0 equals something. Well, 7 minus 0 would equal 7, and what this would be is the zero principle of subtraction, because we're subtracting 0, and subtracting 0 does not change the original number. So that was your zero principle of subtraction. So we've talked about the four properties, and then to finish off this lesson,